So looking at the agenda, what we've gone through is basically identifying our assets, identifying what's vulnerable, then with that vulnerability, you'll be able to patch your systems or secure them in some way. And then we looked at pen testing to see if you can bypass security. And then we moved into packet analysis to determine bad traffic on your network. And from there, we went to our intrusion detection system that helps automate that bad traffic alerting process. From the bad traffic alerting process, we then looked at what was referred to as similar or session analysis. And so basically you create your alerts, you get alerted, and then you go investigate. And we followed through an investigation yesterday afternoon with Security Onion. Then I also showed you some scripting that you could do with TCP dump, and you could probably replicate it with T-Shark as well to look at more than one packet capture at a time for certain traffic types. And we looked at that, pulling out DNS names. We looked at clear text passwords and extracting that information. Now we're going to add another extension to that. That's where we're going to do a more detailed security monitoring. And this is where we do endpoint protection. So there are tools out there that are basically a one-stop shop. Vendors will sell those to you. CrowdStrike, for example. Microsoft has Defender and Sentinel that work together to see what status your security posture is at. We're going to use an open source tool, and it's going to be called Wazza. And there's different components to that, but we're going to start the lab because it takes a little time for it to start. So I'm just going to go open new tab, or you can just open it in your browser depending on how you do it. Make sure if you get a pop-up warning you to allow pop-ups, allow that pop-up. I'm just going to log in off screen. So we've got this security monitoring and analysis lab. So we click on launch, say yes to that. Hopefully it starts. Now, all the installation has been done for you. I think I put a link on the events page for a YouTube video that shows you how to do it. Can't quite remember. Oh, no, I haven't. So my resources aren't there. So I'll need to add those in there. One other thing I forgot to mention is if you scroll to the bottom, there was a couple of questions yesterday about setting up the pen test lab. So here is where you can download the VMs that are in the Virtual Academy. So you've got Kali Linux, you've got the Metasploitable 2, which is the Linux system. You've got the Metasploitable 3, which is the Windows system. And then I've linked to a couple of repos on the documentation related to that. And then if you want to set up the Metasploit framework separately to Kali Linux, I've given you a link there as well. But the idea is that you would download those virtual machines. This one is very easy. It's ISO, whereas this one is a script that you run on a Windows installation. So it's a little bit more complicated to set up. So what we're going to have is one virtual machine that is going to be our Wazza server. And then if we go have a look at the resources tab, we've got two other machines. We've got a Ubuntu desktop machine and another CentOS system that we're going to use to monitor. So we're going to basically deploy agents from the Wazoo server to these systems and start monitoring those systems. And we can do everything that we've done in the past 3 days using this server. So we can do a vulnerability scan. We can do, I didn't talk about cryptography, but we can do a file integrity management, make sure the files haven't been tampered with, and all sorts of things. So let's go ahead and do that. So click on next, but essentially what we're going to be doing is here. We're setting up our manager. We're adding agents to our systems. Then we're going to try and do some sort of attack against that system and see if the server will pick up on that attack and alert you to that. Then we're also going to add the file integrity management module. So that way there are certain key files on an operating system that you shouldn't change. The example might be when someone adds a new user account, you could monitor the files where that's stored to see if there's new user accounts created. And then we'll do a scan looking at the vulnerability management. More advanced sessions, we go into memory analysis, but we won't do that for this workshop. But this looks at live forensics using memory analysis to find certain malware. But it's available there. All of these are in PDF format. I've now converted the first section into an online setup for you. So the first thing that we're going to do is just learn about the Wazza server. So we're at that interface here, and the username is Wazza-user, and the password is Wazza or Wazoo, depending on what you want to call it. So I'm going to log into the system. We're going to have a look at the IP address, and we need to make sure when we create this virtual lab, for some reason, I don't know why, but some of you, it randomizes the IP addresses for the different systems. There's 3 systems, and you'll get either .10, .11, or .12. I haven't figured out why it's randomizing those IP addresses. So it's critical that you type in the IP address here, because further down in the documentation, it references this variable that you create here. So you need to do the 192.168.100.11. If I don't reference it a bit further down, or maybe on the next page, yeah, here it is here. You will see this variable name hasn't been updated. So until I press enter on that field, it will always look like that. So if you see this, it means that you've skipped adding that IP address. So as soon as I press enter on my keyboard, see how it has now changed to that variable that I put up there. So you may not all have 100.11. You might have a different IP address for your server. So make sure you put that into that window, that little text entry box there. So we're going to then check our status. So hopefully it's had time to boot up. So we use the systemctl status Wazoo indexer. And this is saying whether it's running or not. And we're looking for this green active running section. Has everyone been able to get into the virtual machine, get your IP address and update that field? We're now going to switch over to our desktop. And in this instance here, we can't actually, it's not, you might be lucky, but for me, it's not using the full window. So you can set a manual sizing of the window by opening up your terminal. So Control-Alt-T will open up your terminal window. So the keystroke is just here for you. And we can use this command xrandr Alt-S to set our screen resolution. And I'll need to change that because you can't see it. I can barely see it. And that's made it smaller, has it? Yeah. For whatever reason, because they haven't installed the virtual machine tools in this, I can't do that auto resizing. But I will make my screen a little bit bigger. Maybe I shouldn't have changed my resolution. It would have been perfect for what we wanted. Oh well. So I'm not going to do I'll give up on that. I'll come back to that. So what we're going to do is that we're going to try and fit the window to machine. Oh, no, that's not what I want. So we're going to open up our Firefox. So we click on the link down in the bottom left-hand corner. We go to Internet and we go to Firefox web browser. In the Firefox web browser, we're going to go to our IP address of our Wazoo server. If you've got your server IP as being .10, you can just use the shared link that's there already. But I'm going to do the... No, I'm not going to do that. I'm going to use the type text clipboard http://192.168.100.11. That's my server IP, and I click on OK. I press enter, and in theory I should have got some information there. I'm just going to shut my session down, start again. The latency is just getting a bit too much for me. I'm just going to change it to Europe. Hopefully it'll make it a little bit better for me. Oh, this is even worse. So see how I've just restarted my lab and it's now got a .12, whereas previously it was a .11. So that's why I've had to create this variable to reference in our lab guide. I haven't figured out why it does that, but that does it. And I know the status should be up, but just in case yep. So now that's up, I can go to my Ubuntu system. I'm not going to change my resolution because it's probably 800 by 600, and that should give it easier, make it easier for people up the back. And I'm going to go to this website here. And now my latency is a lot better by going to Europe. Yeah, it's just random, depending on when you start it up. So I'm going to go to this warning where it's saying that you're not using a secure connection. So I'm not using encrypted. So I've got to go to the advanced and I've got to accept the risk, or I can view the certificate and add that as a trusted certificate. Something to be aware of. See how it's redirected me from HTTP to HTTPS, and it's still saying there's an alert. If you're going to be logging into tools on your system, so I'm showing you all these different tools, but I'm not showing you how to set them up for a production environment. So you need to think about that. For a production environment, clear text protocols are a no-no, because even though they're on your internal network, people can be listening to that traffic. So you need to still think about self-signed certificates or registering, and with Let's Encrypt, it's an easy way of being able to have a proper certificate if you want to do that. So what you're going to get is this interface here, this open source security platform, and we're going to log in with the default admin. And I never save passwords, so I'll say that. And what this is doing is talking to the server to then check the status of everything. And it gives me a nice little overview of my agents. So I've got 0 agents deployed, 0 active agents, 0 disconnected agents, and 0 agents waiting to be installed. What we also have is different modules that are available. So we've got our security information management, so different events will show up. We have policy monitoring, system auditing, and integrity monitoring. And then finally, security configuration assessment, and we've got threat detection. There's a lot of different standards and actions that you can do using this one tool. So let's have a look at it in action. So what we're going to do is that we're going to go to our main server, and we're going to change the configuration to allow the agent to self-register. Otherwise, you're going to have to do a very manual process of that. But the idea is that you create an installation file and you can push it straight out to the agent. It installs and goes and talks to the server. So we're going to change to our Wazoo server, and we're going to have a look at the configuration file, which is located under var osec etc osec.conf. So another reason why you shouldn't delete things in the var directory. The password is Wazza, and inside here we can see lots of different information. So the global configuration about what sort of output you're going to use. So in this case, it's going to be JSON. Whether to use alerts, we've said yes. What sort of logging we're going to do. Whether we're going to allow email and what the email addresses are going to be used for that. And then what is the timeouts for the agents if they're disconnected. A bit further down, we've got some more alerts. And we've got here email alert, what sort of level of the alerting we want. When we're looking at the logging of information, how do we want to do it? We can do it as plain, JSON, or both. The remote connections and how they will connect to this server. What sort of policy monitoring are we going to do for our intrusion detection? So files, Trojans, different locations and ports, and then the frequency of looking for root check. Some other CIS benchmarks, Java, lots of information is there. What we want to do is to update the password that's going to be used by the agent to self-register with this system. So what I'm doing is I'm going to a specific section. I'm looking for the field use password. Use source, use password. Currently, it's set to no. So with this here, I've said, go search that file for the keyword use password. Show me the 7 lines before and show me the 8 lines after. So I'm just grabbing out that section of information for you. You can scroll through and find this if you want, but essentially what we want to do is to replace this use password no to yes. And that's what this is going to do. So all I said is search for this string where we've got use password no and change it to use password yes in that file. So it's now going to replace that with the letter yes or the word yes. If you want to, you can manually enter and edit the file rather than using this search and replace. But for me, I like to do search and replace because it's easy to document and you don't make mistakes. Now, this is going to now allow me to use passwords for the authorization. And to use the password in this same directory as this config file up here, we can place a file called authd.pass. And we can just create that. Let's have a look. ls. Oh, that's not what I wanted. ls var So in this directory, where we've got our configuration files, we can place that password in a text file inside that directory. So we're going to call it authd.pas. So we can use the text editor. I'm just going to use that one. So authd.pas, and then we can type in a password here. Probably not a good idea to use clear text. There is more advanced way of doing it, but we're just starting off simple at this way. And inside this, we're just going to type in, please, 123. That's it. It's just a simple text file with 1 line of information. Control O to write it, Control X to exit. We've made some changes to the configuration file. What didn't I do? Like yesterday when we were modifying configuration files, what was the first thing I suggested you do? Do a backup of the file. So that way, if you make a mistake, you should go back. I'm surprised no one didn't ask that question already. So don't forget to do a backup of the file first, just in case you make a mistake. But we've made a change, so we have to restart the server. So that's what we're going to do here. So we do sudo systemctl restart WSZR, and it's dash server, dash manager. It will take a time for it to restart, so just be patient while it tries to restart. Hopefully, we haven't made a mistake and we get it come back like that. The way to check is to check the status, so you can go back. So arrow up, use your arrow keys to go back, and we should see that we have active running. And see, now it's got this started Wazoo-Auth D. So in theory, it should be using that new password that we created. On top of that, there should be a socket listening for connections on port 1514 and 1515. So that's how the agent is going to communicate with the server. So if I do a ls-pi lsof, we can see that we get a whole heap of listening ports. But down the bottom, we can see those ports accepting connections from anywhere. We can ignore some of the connections by just saying, go for the keyword listen. And so it just gives us a nicer, whereas these ones established and there's other ones that are there. So that's how we can just pull out what is listening on what port. How's everyone going with that? Hopefully everyone set up that authentication. Yep. We're now going to go back to our client machine, not the desktop, but a client machine called CentOS-Wazza. Now, I'm going to actually get the IP address of this machine, and then I'll go to my desktop and SSH in, because then I can change my font size a little bit easier. So the login is APNIC training. I've got the password right. And I'm just going to do a show. No, I have to do an IF config. So for my IF config, this one is 100.11. So because it's quite tiny, I'm just going to use my desktop to show you the next sections. So I'm going to jump over to my desktop. Control-Alt-T. I'll modify my preferences so you can see it a little bit easier. So I'm actually on the CentOS machine. I've only used this desktop because I can use a terminal window where I can resize it easily. Otherwise, I've got to go into my configs and change the prompts that way. So now that we're connected, what we're going to do is we're going to create a text file. Inside that text file is information that is needed for the agent to connect. So if I open up Notepad, bring this over to here, what we're going to be doing is that we're setting up this WASA repo, going to GPG check equals 1. We're telling it to go to this repo and download the public key to trust this repo. We're then going to enable it, and then we're telling where we can update from for this Wazoo repository. So this is a way of using our install to go and connect to a custom repo to download the installation files. That's our first part. Once we've got that, it's going to be copied from our working directory into the directory that CentOS uses for its updates. Finally, we're going to then use a custom installation. So I'm just going to show you this here. So normally, the past few times we've been doing labs, we've been using Ubuntu, which is a Debian-based Linux system, and it uses the apt-get install command or the apt install command. For CentOS, it uses Yum, which is yet another, something update manager. I can't quite remember. But it's an update manager. It's like saying apt-y install. So that's very similar. Only difference is that we're adding a custom repo by using this file. And so it's going to go look in this location for this agent and download it. Once it downloads, it's going to install. But it's going to need some extra settings. Remember, we created a custom password. And we need to tell it where the Wazoo server is. And so as part of the installation process, we're creating these two variables, Wazoo Manager and the IP address of that. So this will be different depending on what you put in that first box. So mine's 12, yours might be 10, might be 11. And then the registration password that we created in that text file. So it adds some extra features. So it does it at installation rather than installing and then going in and modifying a file. So all I've done is I've basically said here, everything from my screen output, send it to this file until you see these strings, EOF in capitals. And so 1, 2, 3, 4, 5, 6, 7 lines, and then it sees EOF, so it stops. And that's why it's jumped back to the prompt. And then I'm saying we're going to move that file into this directory. Password is training or lowercase. This is case sensitive, so make sure you use the uppercase for both of those. So it's easier just to do the type text. And what that should do now is hopefully go off and grab the latest files and dependencies that are needed to install that agent. As it runs and creates the agent, it uses the IP address of the server as well as the password of the server. And we can see here that it's added our package and started to download the agent here. The main thing to be aware of is you use your IP address for your server, Wazoo server. If you use mine, it's going to be different to yours, maybe. So you might not get a connection because it can't find that server. So what it has done, if you didn't put your password in during that registration process, you will need to go and create it in the same similar location as what we did on the server. But as part of our installation process, we gave it the password. It then goes and creates this file for you and it puts it in here. So if you made a mistake previously or you forgot to add it, you could then add it here and that would then fix that problem. Or remember how we typed it into a command? If I have a look at my history, what do you see in my history? What can you see? The password. So that could be a bad thing, huh? So you can clear your history. So you do history-C and then enter, history-W to write it back, and that gets rid of that history if you make a mistake and accidentally type your password as a command. Or you can go directly to the file and modify it and change it that way. So there is reasons for doing that as well. So just showing you how I can clear my history-C and then I always find -W to write it back. And now if I do the keyword history, see it's not there. Okay, just a little trick. What we now need to do is to reload our agent and tell it. So what we're going to do is we're saying sudo systemctl daemon reload. So this is going to tell the operating system to go look at all these services that need to start up when the system boots up. And so we've just installed a new agent. We want that new agent to auto start. And so that's what that's going to do. It's going to create that list and add the Wazoo agent. I'm now going to say enable that agent and then hopefully it should come up. See how it's created this symbolic link? It's saying go put it in the systemd directory to run this agent. And then we start it by using the start command. And again, it's going to now attempt to communicate to our server, authenticate and self-register with the server, and hopefully it will start feeding information to the server. It's a little bit different to check the status, but you can go into this text file called agentd.state, and it should tell me there the status as being connected. So that means my password's correct, my IP address of the server is correct. If I use the systemd and look at the status there, all that's going to tell me is some alerts and whether the system is running. So if I scroll up, I can see that the program's running, it's active and running, the agent services that are being run, and I can see some error messages there or messaging that I can go have a look in my syslog, but it's not really going to tell me that it's connected to the server. So that's why we go have a look at that state file and it should get updated to connected. Another way is to use looking for any sort of established connections. And we should see here that we've got a session from my machine going to the server's IP on 1514 on that one of those port numbers that we looked at previously. If you haven't got Netstat installed, actually this is CentOS. I don't know if they support SS, but I'll try that. No, it doesn't support SS, so I won't worry about that. If everything is going well and we've given it enough time for the server to contact the agent and start getting information, we should be able to go to our web environment, do a refresh, and we now see that we've got one total agent, one active agent. From the dashboard, there was a drop-down menu here next to the word Wazoo. You click on that and you can go to Agents here. And this is now going to contact all of the different agents and give you a graphical display of the status of each of those agents. And then if I scroll down, I should now see the agent number, what is the name of the machine that it's installed on, the IP address of the machine that it's installed on, and it's identified the operating system as CentOS. And it's got a green status indicator there. So this is where you can start doing endpoint protection or endpoint monitoring. So this is using an agent. There are techniques where you can monitor systems without using an agent. What is the difference between those? Why would you use an agent?
Make the connection with server. Make this connection with the server set.
Make a connection with the server, yeah. That could be one reason to use an agent, but you can do that agentless as well. You can tell it to,
Yes.
yeah. Better control over the endpoint. Because if you are running an agent on that system, it's going to run with the appropriate permissions on that system. Whereas if you are running it agentless, you're going to have remote calls to that system with escalated privileges. Does anyone see an issue with that? You could potentially hijack that remote call or that API or whatever. Whereas if it's run locally, it also allows it to have the correct permissions. The other reason is that if it's an agent and it's not able to communicate with the server, it can still store information locally. And then when that communication restores, it will then share that information with the server. So if you've got users that travel a lot, for example, I travel a lot, so the next time I log into my work environment or into the internet, it can then talk to the servers and update what's happened and those alerts. Whereas if I'm polling for information from a server that is going to a client and I don't have the connection, I lose that information because it's not really being stored anywhere. Does that make sense? Okay, so that's one agent that's been installed. Now that we've got an agent, this is where we can start using the power of the Wazoo engine to start getting that agent to do certain activities, and we start collecting information about that operating system or that endpoint device that we're monitoring. So we're going to start with a simple one, and that is where we want to look at our vulnerability management. So we're going to set it up so that way it enables our vulnerability software, or tell the agent to go check for vulnerabilities on this system. So going to our main server, we're going to update our configuration. In particular, if we go have a look in our down on line 104 to 168, what I've done is I've basically pulled out the main sections of that vulnerability detector section, just the headings. And these are the operating systems that are supported. If it's not supported, you can go have a look online and look for maybe some fixes or other walkthrough solutions to use it. So you might be able to use, so see how we don't have CentOS here? You can use an alternative operating system to do a similar thing. So we've got some basic ones there, but it supports a lot of the Linux-based systems, the Windows-based systems for our vulnerability detection. So it's not a perfect vulnerability detection system, but it does cover a lot depending on what you've got there. And there's no Mac. Notice there's no Mac, but you'll need to look up FreeBSD or something like that. If we just go have a look at the system, so I'm just looking at this top section here. See how I've missed quite a bit because I've just pulled out the headings. So what I'm doing is I'm looking at whether it's enabled. Currently, it is not enabled. So I'm going to enable that, and then I'm going to update it to use CentOS. So the first thing is I'm going to replace the no that we've got here with the word yes. So if you want to edit this using a text editor, you do sudo vi plus the line number and the file, and then it will jump you down to that line number and you can replace it, or you could use nano. I'm just going to use a search and replace because I know exactly where I want it to go. And I press enter, and I'm just going to extract that information again to make sure it changed it. And we can see it's changed from no to yes. Main thing to be aware of is that your server, you don't want to, you possibly could deploy an agent onto your server, but in our lab environment, we want to deploy it on a separate system. So make sure you point it at the CentOS system. So in the instructions, it tells you the hyperlink here to change to log into that system. So make sure your prompt matches the correct system. I may have got people confused because I did it from my desktop just so I could show you what I was doing. But in theory, it should be this one. And notice that the prompt, it says apnic at localhost. Maybe I should change it so that way the colors are different. My terminal colors are different. So for those people who got their agent installed, if you go to the events page and do a refresh, I've added in here some extra links. So if we do a refresh, you should see that there's a few YouTube channels that you can go have a look at to learn more about it. And there's a Try Hack Me threat and vulnerability management room that you can go have a look at. But these ones here, so someone I know did this one. They're about 2 minutes to 5 minute each video, and it steps you through how to install Wazoo server and then how to do different configurations with it. These ones go into a lot more detail, but if you just want a quick overview, the top one is quite good. There's a lot you can do with the server. So essentially what I've done is that you've missed out on installing the server, but there's an OVA that you can just download off the internet and you can import that into a virtual instance and start using it. But you go in and I've set it up so that way the server has a password to allow the agent to connect. Why do I want to set up that self-registration with a password? Security? In a way, yes, because if I just allow any agent to connect, could a malicious person then try and use that to dump fake information into my system? Yeah, so you want to try and control that. So that's why we did that password. The installing the agent on an endpoint device, in this case CentOS, we did that so that way it gives us a lot more information and we've got more control over that. And the process of installing it is different depending on which operating system you're using. But essentially, you need a variable to say where the IP address is, and you need a password to allow for that self-registration. And you need to download it from wherever the official source is. So that's all we've done at this point. We then went to the web GUI and we refreshed that web GUI and it started collecting some basic information. The operating system, the name of the system, the IP address. So if we want to do vulnerability, I hope to get this done before the break because we'll let it run during the break. Because it takes a time for it to refresh. But we're now enabled it by going in and changing this from no to yes. But then we need to look at our settings for our operating systems. And I gave you a listing of the top headings for the different operating system. And CentOS is not listed there, is it? So you can go online, look at the documentation and look at what is the recommended settings for your not supported operating system. So we're going to look at our Red Hat, and in particular, we're going to see here a basic setting. So it's going to say Red Hat OS, provider name equals Red Hat, and it's not enabled at this point. So even though we enable the vulnerability detector up here, each one of these need to be enabled separately. Now you might say, why don't we just enable it all? Doesn't make sense to do that, especially if nothing in your operating environment is running those. So you should only enable the OSs that you have as your standing operating environment. So we need to then also enable our Red Hat OS, and we need to add in support for the CentOS operating system that we're running. So we're going to do the same thing as before, search and replace, arrow up and just make sure that my search pattern hasn't broken something. And we can see here that it has been enabled. It's got yes. Usually what happens is people install the agent, go to this configuration and go yes, and then let it run. And they're saying, it's not working. Why isn't it working? Because they haven't gone to the specific operating system and enabled it in there as well. I then scroll down and I'm going to, actually, I might just change my grep. And I'm going to just increase that from 2. Well, the control key doesn't support. Let's try 10. It's probably going to be a bit big, but we'll get what we wanted. So that's what I wanted. So we can see here under the OS, it's saying which versions of the operating system it supports for this scanning of a vulnerability. If you're not using 5, 6, 7, you can go in and delete or comment out these lines. Okay. Now, I know I'm going to get error messages because OS 5 is well and truly end of life. And it's no longer supported by the Wazoo agent, even though I've enabled that operating system. So just be aware of that. So I'm going to restart my manager. Takes a little while for that to happen. And just to make sure I haven't got a typo, I do a status. And I've got the green active running up there, and we can see that it's done the completed, starting all of those different modules. One of the modules that we are interested in is the SIS collector. What happens is now that I've enabled the vulnerability module, it's going to tell the agent, start collecting information about your operating system and store it. Then I need to share that with the server, and that's where the SIS collector comes in. It's going to go and grab that information off the agent where they've stored it. So we need to make sure that that has started. And if we go have a look at the OSSEC log file, I've told it to check the log file for anything that has the SIS collector. And this is where you need to check that the module started, it's starting the evaluation finished. But down the bottom, we should see that. So this will be a schedule, and it will keep polling for updates from that agent. If I want to look at the vulnerabilities detector engine, I do a search in that same log file for our vulnerability detector. And we should see here, vulnerability detector starting Red Hat Enterprise Linux 5 database update. What it's actually doing in the background is that there is a database of vulnerabilities, CVEs, common vulnerability exploits, or sorry, CVSs. And those CVSs, you can get updates about that. Just like how your antivirus software gets signature updates and so on. So it's now requesting for those updates. And we can see here that for version 5, it couldn't be found anymore. So it's useless having that in our configuration. We can get rid of that. For version 6, it started the update and finished successfully. Version 7, it started and finished. And that's what you should be looking for, that it's doing a database update and it finishes successfully. If it doesn't finish successfully, then you need to go and troubleshoot that. So I'm just going to make sure, because it was a bit off, but I can see here that it's gone to the JSON, so it's still updating, so it's nearly finished the update. Once it finishes that update, it's now going to use those to ask the agent to do checks. password is training. If you've gotten to that point, you should now be able to go to the Wazoo modules, and under the modules, you should see under threat and detection, vulnerabilities. This is a little bit different. So I'm going to select my agent, and it's going to basically hasn't started a scan or getting information at this point. If you've gotten to this point, we'll stop for morning tea and we'll leave that running. Don't put your lab to sleep because it can take quite a long time for it to go and poll and get that information. If you need assistance, please get my attention. So some of you had a bit of issues with getting the agent to go to a connected state. Usually what happens is that your password doesn't match the server or your IP address doesn't match the server. The only other thing I thought of at the last minute was that you can go and have a look at the logs to see what the status is. So you know how we enabled our server and then I got you to go have a look at the sys collector and vulnerability. We can do a tail of the ossec.log file and see if there's any error messages on the agent side about connectivity. But usually what I do is I ping the IP address of the server to make sure I can communicate with that server, because you might have VLANs in place, you might have network segmentation in place, so it physically or logically can't get to that server, even though you've got the correct IP address and you've got the correct password. So that could be the issue there. The other thing is that you do changes to the configuration, but you don't restart the server or the agent, and so it won't pick up those changes. So that could be the other reason for it as well. So this is still running. That's okay. We can come back to this and leave it running in the background. But essentially what it's going to do, it's downloading the database, it's compiling the database, and then it's asking the agent based on its operating system to check for vulnerabilities. And hopefully it will give you some details about that. And as I said, it can take a long time. I haven't tried it with high latency, but I know it anywhere between 30 minutes to an hour before it starts populating. So it's not something that you get instant response to. Just like how we schedule or scan with the Open Vulnerability and Assessment scanning tool, it took a little while before it showed you that, and I got you to look at a previous report. So why do you think it's important to do some sort of vulnerability management from a security point of view? Why is it important to know what patch level you're at? To fix it, yeah. How many of you have an iPhone? Yeah? How many of you updated in the past 2 days? There's a critical 0-day attack against iPhones and they pushed out updates this week. So you should be updating. How many of you have Microsoft system? Windows, yeah? They've also got critical remote code execution, I think not quite a 10, but very close to it. Have you done your update this week? In theory, you should say yes, because we did it yesterday when I did the Windows update. No, that only does your applications. But have you done your update rather than waiting for the operating system to update? When I worked for a managed service provider, we had different tools that were agent-based that allowed us to know what state the machines were at, so we could then push out applications, push out updates, and schedule them on our time and not when the machine feels like it. Because remember, with Microsoft, they schedule the updates to suit their load. They don't just go, oh, everyone in the world gets this update, because it would crash their servers. So either you manually go in and force an update so you get the latest update, or you schedule it somehow. And that's what vulnerability management is doing. It's making sure that you've got that. The other thing is that, for example, in this room here, there's at least 50 different machines. And if they're all running different operating systems and different patch levels, it becomes a nightmare to support. One system may not be able to get to a particular website because of whatever setting that is in there, and so on. It's difficult to do that. And I've already had situations here where one person couldn't get into the academy, another person got into a website and it was in the wrong language, and so on. You can't control everything. When I looked after large organizations, I always try to have a standard operating environment. What is a baseline system and what we support? Nowadays that we're doing remote working is probably the best word, and bring your own devices, it puts a lot of pressure on IT support and security teams. And so what they're going to do is they're going to enforce a minimum baseline. Okay, so there are lots of tools out there that help you manage that, but this is just one of the tools. So that's why vulnerability management is important. CVE is a common vulnerable exploit you can go and search for. So it's a little bit different to a CVS score. And the severity means that the higher the number, the quicker you're going to have to patch that system. If it's a 10, then you're in big trouble, especially if it's publicly connected to the internet. So I'm going to jump over to lab 3. Now that we've got an agent deployed, that agent acts as a host-based intrusion detection system. So we can now start testing against that. So remember, your security tool, don't blindly trust it. A vendor's going to sell you what they think you want. And they'll say, yes, when I was deploying systems into the Asia Pacific in the 90s, we had a particular salesperson, didn't matter what the customer asked for. Yes, we can do that. Yes, we can do that. What, you want your computer to hover? Yes, it can do that. We can make it happen. How big is your budget? So it didn't matter, and vendors will do that. So think about the requirement of the tool and test it in some sort of proof of concept. So that's what you need to think about. So if we've got a host-based intrusion detection system, if you're having issues where people are trying to log into your systems all the time, there's a simple test for you to know that it's working, is to try and do a brute force attack against it. And that's where the Kali Linux comes in, where you can do the Nmap scan or you can do the Metasploit, and you're doing that pen test. That's another reason why you do pen tests, is to test the tooling that you have and to test the skill level of your IT team in regard to defending your network. It's not just to exploit the system. It's to also test the system's capability and your defense against certain types of attacks. I haven't put it in this week's workshop, but I can link you to a talk I've done a few times already. There's a set of tools called breach and attack simulation tools. And this is where, instead of trying to get into your network, it works from the point of view where your system has already been compromised. And so it then is attacking or trying to do lateral movement, and it tests your detection tools if you want. We're not talking about that at this point. But essentially, if and when the scan finishes, it should show you the name of the vulnerability, the severity of the vulnerability, where you can get more information about that. So that's CVE, the score version 2 and version 3, and how long it, I can't quite remember what the detection time is, but yeah, just be aware of that. So I'll refresh once more to see if it's there and populated. If it hasn't populated anything at this point, I will move on. Okay, so I'll move on at this point. So what we're going to do is that we're going to go in and we're going to try and log into our CentOS system. Now, I get you to confirm that OpenSSH is running. I know it's running because I've done that already when I'm using my setup. We're going to look at the IP address so you know what it is. And then you're going to put the IP address here. So I'm already logged in, so I'm just going to do the I don't think the IP-brief works. I think it's ifconfig. And so in here, I want to get the IP address, and it's 192.168.100.11 for me. And that's going to update the instructions that we've got here. And all I'm doing, instead of using a third-party tool to try and do a brute force, I'm just going to use random accounts to try and log in with fake passwords. So causing some sort of failure at login. So I'm just going to open up a new tab, and I'm going to just use the SSH random at 192.168.100.11, and I'm going to type anything in for the password. It doesn't matter because that account doesn't exist. I press enter. It's going to ask me for the password again. Press enter, and third time lucky, I still don't get in. And I'm going to do that a few times. So I'm going to try and log in to an account that I know exists on most Linux systems called root. So let's try that. And again, we're going to type anything for the password because we just want to cause some sort of login failure. So that's now done 2 attempts with 2 different accounts with fake passwords. Let's create some legitimate events. So we're going to log in with the APNIC account, and the password is training. I'm using the -v. If you don't know about that, the -v just gives me more details about what's happening with the SSH connection. And I can do -v, -v, or -v if I want very, very verbose mode. It's a good way to learn what SSH is doing in the back end. And the password is training. And I'm now connected. So I've now had 3 different logins to that machine that's running the agent. 2 of those were login failures. So what we should be able to do is go have a look at our Wazoo server, and in our Wazoo server, we can go and check the log file, which is called alerts. So we've got alerts/alerts.log. Now, there has been questions about other tools being able to go to rsyslog and so on like that. Yeah, depending on the format of what your logs are, you can redirect this to wherever you're doing your storage of logs. And there will be ways to get it to work with other log management systems. So I'm just going to do a search in that alerts folder for anything to do with SSH. And where we can see quite a lot of SSH. We've got our SSH authentication success here, but then we've got up here, failed password for root from this IP address, failed password for root from this IP address, and authentication failed. So we can see that it's got authentication failed in that log file. We can also look at the JSON format of that because we've set it up to log both plain text as well as JSON format. So we can use the JSON query tool, and it's not installed, so we won't worry about that. So to install it, we just do the sudo yum. We've got two tools that we need to install. So we need to do the EPL release, and then we need to do the JQ tool. Once that's installed, we can run the JQ query, and it just pulls it out like what we were doing yesterday with Suricata. So it lays it out in a nice format, and the advantages of the JSON format is that you can now send it to other security event and incident management tools. You don't just have to rely on the Wazoo engine. But I know you don't like the command line, so let's go do it in the GUI. So going back to our web interface, from the drop down here, we can have a look at our security events. We click on security events, and we should now start seeing information about our alerts. So we can see here, SSHD, attempt to log in using a non-existent user. So remember, we did that random at blah, blah, blah. So if we had someone trying to do a credential stuffing attack or some sort of brute force, and they've just got a list of usernames and they're trying to use various passwords against that username, it would be flagged. However, on the other side, we've now got authentication failed. And that's going to be because the passwords didn't match. So if we scroll down, we can now see some of the information that is related to this. And this is one thing I really do like about Wazoo, is that it tries to give you the tactics of what it's trying to do. So under the MITRE ATT&CK framework, it's telling you here that it's got listening port. No, that's different. Here. So the tactic is T1078, and it's a hyperlink that you can go and get more information about. It tells me the tactic that someone's trying to use: defense evasion, persistence, privilege escalation, initial access. And then you can see what was the rule that alerted on. And I can scroll down. So some of these are false positives. So that top two may be false positives. But if we go and have a look at this, we've got this one here, credential access. User missed the password more than one time. And we've got 10 alerts on that. And this is the tactic that was used. And then it's got SSHD authentication failed, the two different types of tactics from the MITRE ATT&CK framework, so credential access and lateral movement. Then it's got the Unix check password, password check fail, and so on. So you can now drill down on those to get more information. So we've got internet connection. So I'm just going to right mouse click on that. It doesn't allow me to. I tend to try and get it to open in a new tab, but we'll just click on it. It's actually got the information in there. So this is a group tactic that they try to use. So here we have here, adversaries with no prior knowledge of legitimate credentials within the system or environment may guess passwords to attempt access to accounts. Without knowledge of the password for an account, they systematically guess the password using a repetitive or iterative mechanism. So it breaks down exactly what the tactic is that they're trying to do. So I'm just going to take that back. Hopefully it gets me back to where I want. If not, I'll do it the manual way. I'll go to security events again, and I scroll down. In theory, we should see that we've got this authentication failure here. Now, if we want to filter based on those alerts, see how I've got a hyperlink there? I can now click on that hyperlink and it will take me directly to those alerts. My screen is massive, so I can't find out, but we can get a nice picture about it, and it tells you exactly information that is related to those alerts. Authentication failed, came from the syslog and so on. And then we get those same alerts, but being shown here. Now, when you are doing login access auditing, should you be auditing successful logins? Yes or no? Hands up if you think that you should audit successful logins. I've got 3 people, 4 people, 5. Should I be auditing successful logins to a system? So if someone logs in successfully, should I create a log about that? Yeah? Yeah, you should. Should I be auditing unsuccessful logins? Yes. Yeah. In the past, there used to be a recommendation, especially in the Windows world, because it caused too many logs, don't record successful logins. But the problem with that is that if someone's doing a brute force attack against your system, how do you know if they got in? And what account did they get in on? So by auditing the successful login, you're able to then see all these failed logins and then an account logged in. So you now get the account name at least and you can go investigate. Even though it might be legitimate, it's something that should create alarm bells. But yes, you should be doing success as well as unsuccess. Being aware though, you need to store these logs somewhere and they can cause a lot of extra alerts that you may not want. The next lab, what we're going to do is that we're going to get the agent to monitor specific files on the operating system. In theory, there should be certain files on endpoint devices that should never change. So if you know that there's only one person using your laptop, all the accounts should already be created, so therefore no more accounts should be created. So if someone's able to compromise your laptop, one of the first things they're going to do is that initial foothold and add a user account. So that way they don't need to use your account anymore. Like what we did on day 2, where we compromised the Linux system and then we added a user called Not a Hacker. So we're going to start monitoring things there. So what we're going to do, I'm not switching over to my CentOS system, but I'm monitoring that CentOS system, and I'm going to have this syscheck var os etc. So what I'm doing is I'm trying to find this system check capability in the configuration file. And then I'm saying, show me 25 lines after you find that string. Oh, helps if I'm not in the right window. Make sure your prompt says APNIC at localhost. So what this has got in this configuration section is whether it's disabled. In this case, it's not disabled. What is the frequency of being able to view the system's checks? So in this case, it's about 12 hours. Scan on start. So when the system reboots, you want it to scan. And then what directories do you want to monitor? So the bin and the SBin are usually binary files. So if someone's installing a payload on your system, it will most likely go into those directories. Inside the ETC directory is where you've got lots of configuration files. So if someone's trying to modify your services or your installs, they would change something inside there. Some important files in there are your password file, your shadow file, your host name, and DNS settings like resolve.conf. So that's important as well. Then another way to maintain persistence is to get your bootloader to reload your software when it restarts. So you can use changes inside the boot folder, the configurations in there, to get it to, every time it restarts the operating system, to reload your malware or your spyware or something like that. Underneath that, we've got the directories to ignore. So there are some directories you don't want in there. And these are the default ones. And there is no right or wrong way of doing this. I would suggest go read the CIS benchmarks for your operating system to figure out what is important files. There are other, I think on this events page, if we go to the events page, I don't think I've got a link there, maybe a bit lower down. There. This is what to log, probably not the same. When I do my hashing lab, so there's a virtual hashing lab, I think I've got links in there where it suggests which are important file system files that you should monitor in regards to Windows and Linux. I'll see if I can find the link and throw it into the events page. So what we're going to do is we're going to add in our other directories to monitor. Currently at the moment, we haven't said that we should monitor these directories. So we're going to say check all inside this directories, and then we're going to specify that it should do it real time, and it should do it including the home/APNIC. And that's what I'm doing as I search and replace here. So essentially what I'm saying is go find the key string directories, etc directories close bracket, and replace that with etc directories, check all, yes, real time, yes, who data, yes, and then all the directories that I want. I've added in the etc directory, the APNIC directory, and the And that's it. So hopefully that's now updated that. So what we can see when I scroll back up is that first directories to check, I've now changed it to include more. So I've got check all, yes, do it in real time, and monitor the etc directory, the home APNIC directory, the user bin, the user sbin directory. So now if there's files modified or if there's files that are created in those directories, you will get an alert. Obviously, we've done a change, so we've got to restart our system. So I'm just going to do the sudo systemctl restart agent. Takes a little while to do it. And we should see that it's got started down here. I'm going to start, I should have added this into the might just do a I hate how I can't scroll it. Oh, it's not there. I wonder where it's putting on. It's a laptop. I'll come back to that. So what we're going to do is print our working directory. So inside our working directory, we can see we're inside the home APNIC. And we can create a file inside that directory, and I'm just going to call it message.txt. So I could just use touch or something like that. And it dropped out the, so that will not do exactly what I want. So I'm going to do it this way. So it's now added that to my message.txt. I'm also going to go in and this is something that malicious actors will do. On the Windows system, it's called, it's host file as well. But what happens from a DNS point of view, a system is going to try and convert a name to an IP address. And it looks in multiple locations. First, it will look on the local system. Then it will look on the local cache. Then it will go and talk to the DNS server. So what malicious actors will do is they're going to manipulate your DNS settings in this host file to make it look like if you're going to your bank, it's actually redirected to a different IP address rather than to the real IP address. Or if you're going to Google, they might have a cloned version of the Google search engine that sends you to the wrong thing. So we're going to add in here 1.2.3.4 and we're just going to give it a unusual name. So I'll just say backdoor.xyz, unless it's just XYZ. And I'm going to save that. So I've now done a change in my home APNIC directory. I've done a change in my etc directory. So in theory, that agent should have picked that up and told the Wazoo server about that. I'll also do a change to my name server. So it's done that. So going back over to here, going to do a refresh. And we're going to drill down and go to our integrity monitoring. And we can see here the names of the files modified and the names of the files that have been added. So you can now drill down for further investigation if it looks suspicious. So if I click on the APNIC message, well, that only changes the color. But we can get there. I'm sure I've got a view. Up here, events. Rather than dashboard, go events. And here is where I can see what's been changed. So I get etc resolve hosts message.txt. And if I click on that, it's going to show me the actual hash value of that. And that's how it keeps track. It doesn't look at the contents. It just does a hash value of the system file or the file. So if we go have a look at this one, the hash value ends in 360 or 6E0. And then if I go to the modified, well, it still ends in 60, but it's different here. But we can see here that we've got the file added, integrity changed, integrity changed, integrity changed. Any questions about that? Have you been able to get that to work? So it looks like my severity levels haven't, or my vulnerabilities haven't come through. So I'm just going to check a few things. So on my server, if I want to get a list of agents that are connected to the server, I can use the var osect bin agent underscore control -L. And in here, I should see I've got that localhost.local domain IP any active. So that shows me I do have the agent connected. There's also another one that we can use, and that's going to be the Wazoo control, and see what it supports. And so what this is going to give me is the version of my Wazoo server and the type in this case. And so I can then go and grab or go research that for anything. To check the state of my downloads, we've done that already. So I need to double check what's happening there using the sudo grep vulnerability detector. Let's go and see. And currently at this point here, it had started. So it's still doing it by the looks of it. Detector agent 01, software could not be requested. So there's some sort of issue. Could not be attained after 5 attempts. Starting Red Hat, CVE database commit. Finish vulnerability assessment for agent 0. So it did it for agent 0, but it didn't do it for agent 1. Software could not be requested. So there's that issue there. I'm going to just go over to the Wazoo server using my bigger shell. And I'm going to look at the same sort of information. I want to see what the Wazoo control info is there, because depending on what we've downloaded, it may be a different version. That could be partly why we've got issues. So 4.7.4, and we can see that it's an agent. And if we go to our server is 4.3.6. So it's a few versions behind. So maybe because of our versioning, we've already had the server set up. It's got issues from there. So I haven't run this year, this lab. So I need to look at updating the server environment. I'm just going to check the database to see what we've got. So sudo ls-lash, and inside the var osec directory, there is this queue. And inside that queue, you can see different information. So you've got your log collector and so on, the sys collector. We're interested in the bottom folder, which is vulnerabilities. And we can see that we've downloaded the CVE database, because sometimes if that database doesn't get created, it won't be able to do the scan. So just making sure that's there. And it's quite big. It's currently nearly just under a gig in size. Just going to try installing a network monitoring tool. So sudo yum -y install suppose I could possibly just use TCP dump and have a look, but what I'm doing now is just saying what sort of traffic is coming in. So I can see I've got a connection to 11. And there is a lot of transfer happening. Oh, that's my, yeah. And it's on port 1514. So there is some communication polling between those two, between the agent and the server. Can everyone see that? And this is just a different tool that shows similar output. And so, yeah, I can see that there is traffic going both ways between the two servers. So it's sending something, as you can see here, because the traffic's going the other way. But it's still not enough. What's that? Oh, okay. So first up, because it's a Linux CentOS system, you're going to have to install the software, and it's install EPEL release, and that's just getting the required tools. Then sudo yum, I'll make that bigger, -y, and then the tools that you want to install, and that's going to be iftop, so install iftop, and you could do the jnettop. Once you've got them both installed, to run it, you just do a sudo, the name of the program. So if we wanted iftop -i, the interface to listen on, not capital I, and ef0 as the interface. For the jnettop, you just run jnettop. To get out of the interface, you just press Q by itself. I'm just going to go back to my client and just see what's in its logs file. So, might do a tail, sudo tail var osec logs. Maybe it doesn't exist. And let's have a look here. Oh, it worked that time. That's good. Starting root check scan. So sys collector evaluation finished. FIM sync model started, evaluation finished for. So it's trying to run this CIS Linux check. Security configuration assessment scan is there. I might just do a grep to see. Nothing in there for that. I'll do a less and just have a look. What I'm doing is I'm just trying to troubleshoot why the vulnerability management isn't working. So it started, monitoring path. That's the file integrity there. There's my log collector. So we can see here it's been able to detect the version connected to the server. And this is where we did our file integrity monitoring. Doing a root check scan, trying to connect to the server. Wazoo agent error, unable to connect to 192.168.112. So there is some problem there, releasing the lock. Agent is now offline. Process unlocking continue, starting evaluation, evaluation finished. Shutdown received. So all I'm doing is I'm just reviewing the log file to see if I can find any hint of why the vulnerability scan can't work. Whereas we can see all the other modules are working. So I can't see anything there. So I'm just going to try doing a refresh and see if it's got anything at this point. But according to the web server, the Wazoo server, it is crashing for some reason. What I will show you though, if we change this and go to our modules, we can see we've got this system auditing. If you click on the system auditing, it's going to have some information there. And if we click on events and scroll down, we can see that there's been some changes to our audit D. And it will be because it's polling it from time to time. So config changes happen, and it's in relation to our module wazoo_fin. So we can see some false positives there. We go have a look at the other modules. I'm trying to find, that's GDPR, data regulation. We can try doing a security configuration. Here it is, that's what I was after. So the security configuration, what it's done is it's detected that we're running the CentOS on this agent. And so it's gone and grabbed the CIS benchmark, and it's now used that to figure out if you're in compliance. And we can see here, out of the 200 or so items, it's passed 77, but it's failed 108 of those. So if you click on the events and you scroll down, you now get an idea of what's happening. So here it's saying that you're using idle timeout for your SSH needs to be configured out. Make sure you ensure permit user environment is disabled. So this is in relation to SSH configurations. So even though the vulnerability scanning hasn't worked, I've shown you OpenVAS will do that. I'll need to troubleshoot the lab and fix that. But it also offers you the automated process of CIS benchmarks depending on your operating system. I still highly recommend that you download the PDF and read it for your own knowledge to understand what it's auditing. But this automates a lot of that process for you. You still manually have to go and fix it, but then you will have a timeline of what you're doing and evidence that you're improving your security posture over time. So there's a whole heap of them. Sounds like someone's lab's about to expire. So go renew or extend. If you want to add an agent, now I got you to do the command line. Where did I get that command line for installing the CentOS agent? Yes, you can go and read the help file. But if I click on my home and go agents, scroll down, and I click on deploy new agent, it actually is a wizard asking me details about what sort of agent I want to install. So I need to scroll to the top. It's jumped to the bottom for some reason. So the first thing, question 1, what agent do I want to install? Oh, they've added it in. So there is a Mac OS agent. So you click on the type of operating system or the category of operating system that you want. So I click on, say, CentOS, because I've shown you how to do that. It's going to ask what version of Red Hat or CentOS. So I'm going to use CentOS 6 or higher because I'm running version 7. Then it's going to ask me about the architecture, the hardware. So I'm going to say it's an x86, and I scroll down and it's going to say, what is the Wazoo server address? It's not installed on this system. For me, it's 192.168.100.12. I can now create custom groups. I haven't shown you how to do that, but you can create custom groups. So you could say building A, building B, or IT department, finance. I'm going to select default. I scroll down, and now it shows me the command to use to run here. Actually, it should have asked me for the password. No, it didn't ask me what the password was. But what we can do is that we can then click on that and it's going to show password. And so now I can copy that and paste it on the agent, and that will deploy the software. So that's how I know what the command was that I needed. Actually, this is probably the better command. Because look, I've specified the actual agent version. So that might be the better way to fix the differences, because I'm running 4.7 as my agent and my server's 4.3.6. So in theory, they should match. Otherwise, you get weird things happening. That make sense? And then to start it, it tells me here, copy these commands to reload the daemon, enable the agent, and then start it. So that's where I got those config commands from. So let's go through and do it for the Mac. Because I see there's quite a few different Macs here. So if we click on a Mac, it's remembered some of the settings already. And in this case here, I'll scroll back up. I've left it all the settings the same. But in this case, it's using the curl command to download my package for the Macintosh. Then it's piping it to a sudo launch set environment variables, which we see here, and then sudo installer package, and then the package target root. Once that's installed, we then start the agent using this sudo library osec bin was a control start. Any questions? I should go have a look at Menti. Oh, there's 11. There's a lot there. So, yes, I mentioned remote connections to servers are unsafe. Any external connections can be deemed unsafe. So how can you ensure that it's safe? One is that you look at specific machines and you add filtering for their IP addresses or something, or their MAC address. So you say this is a trusted connection. You don't, but that's a problem when you're looking at the internet and you've got remote working and things like that. So how do you get around that? There's things like Bastion servers, or you do some sort of way of isolating and using an approved connection of some sort. But just having an API facing the public internet without any credentials is a problem. In Australia, one of the largest ISPs, they had an API that a developer was using to access the customer database with no credentials on it. All I need to do is send an appropriate string to that API and it would return all the customer details to me. So that's not secure, is it? There was no authentication happening with that. There are ways to secure it. The other thing is you could do SSH. So you create an SSH tunnel which now encrypts the traffic going to that server, and then you still do the call to the API. Does that make sense? Yeah, is that way as well. But essentially, you're going to have something listening on a port, and the malicious person needs to know how to connect to that port. Is that difficult to find out what ports are listening? No, we can use Nmap and point it at an IP address. There are tools like Knock Knock. Has anyone heard of that? Knock Knock means that I send a specially crafted ping packet to a specific set of ports, and based on that, it would then open the appropriate port for you to connect to. So it's like a secret knock on a door. Have you seen the movies where they go up to a door and they go, something like that? This software does the same thing. So you then send a ping packet to port 9000, ping packet to 7000, and ping packet at 21,000. Then it'll open up SSH. When you're finished, you then send another lot of ping packets to close that port. What do you think of that? That would be a better way for your secure connections, being able to lock it down. And that way, when the Nmap scan happens, port 22 is closed.
System admin, they want to log into their servers remotely to the internet situations.
Yeah.
So, what's the method you recommend for that?
So, depending on the network that you're running, if you're running, so for example, what we have in the training team, we use a Linux-based system. So we will use SSH to connect to a jump host. And from that jump host, we then go to our systems internally. We also only allow, through our firewall on our systems, IP addresses from our internal systems.
What do you think about taking a VPN?
Yeah, you can have a VPN as well. So VPN will work, but you've got to be aware that there's been a lot of vulnerabilities in the latest a lot of the VPNs these days. So the past 2 months, it's been able to exploit those VPNs. But I would use VPNs. The advantages of a VPN is that it then allows your system to be on the internal network if you want from there. Yes, you can do that. It comes back to whether you are needing tools that need a graphical interface or do you just need a command line interface. from my administration point of view, I just need a CLI, whereas VPN makes it easier if you're using internal tools that have a graphical user interface that you need to have that connectivity with. Microsoft, they have their remote desktop services that you could use. Problem with that, should you be exposing those? So this is where the VPN fixes that problem, because you can do a VPN and then you can do your remote desktop services. There's other tools like Terminal Server, where you run a terminal server in the cloud and they connect to that and everything's run locally on that system. Can you explain how the proxy chain works? Yes and no. I'm still trying to get my head around it, but essentially all it is allowing you to have one or more servers act on your behalf. Just say these are the internet connections between them. And then you might be targeting a system. But essentially what happens is your laptop is going to connect. And let's say I've got an IP address of 10.10.10.1. And I get to this system here. This system on your behalf is going to tunnel your connection to this next system. Now, this IP address might be 172.16.0.1. So this system sees this IP address, not that one. And then this system is going to then communicate to this system, and this might be 100.100.10.20. So this system sees that IP address there. And then from here, this can be the attacking machine as such. But the idea is that you're going through multiple hops to hide your original location. So it's like picking up the phone, ringing, say, your phone number, and then you've got another phone. You answer the phone, turn it around, ring the other number to somewhere else, and then they pick up the phone, turn it around. Have you seen the movies where they do that? They put the old analog phones together. That's essentially what this is doing. And the idea, it's a way of masquerading your original IP address. Tor does a similar sort of technology. The thing, in theory, that is wrong with proxy chains is, in theory, it needs to know how to get back to this. True? So it sometimes, depending on how it's connected, if I'm doing an SSH tunnel, it might still show or leak my original IP address, depending on the software you're using. Whereas with Tor, it uses exit nodes, and you go and connect to one exit node, and that then strips out your information and it becomes the source of that traffic. It then talks to its neighbor. The neighbor then becomes the source. All it knows about is the exit node and then where the next hop is. Then that neighbor becomes the source. So it's a little bit different. It actually deliberately is designed to be anonymizing of your traffic. Whereas proxy chains, not necessarily. It's probably not the best explanation, but that's my understanding of proxy chains. How to identify VPN IPs and restrict them. Is it a good strategy to block them or allow them, as people tend to use VPNs for privacy reasons? There are vendors that keep track of VPNs. There is a list, uBlock list, I think it is, where it looks at IP addresses from researchers, marketing, as well as VPNs, and you can block those if you want. But there are various lists where you can get from various vendors block lists if you want to get those. And it will say, do not allow these types of IP addresses. So there's another one there as well. So do a search. I don't know about any free versions. Again, I worked in a reseller, so we used to purchase those sort of things. Cisco Umbrella has them, Polar Alto, depending on your vendor that you have. Is it a good strategy to block them? Depends on your risk appetite for your organisation. In theory, is there any reason for your customers to be, customers or your employees to be VPN into your work using a third-party VPN? Probably not. So you may want to block them, and there are ways to do that. There are certain protocols depending on which VPN they use, but you can customize that. So if they've got some knowledge, they can customize the connection, and you've got things like Tailscale and things now that help with that. Yeah, I haven't had a cause to block them, but you can do that. Which lab are you referring to for 2 weeks? So all the Virtual Academy labs are there for as long as you can log into them. So they'll be there for the next 2 weeks. But if you're talking about the labs that we did the installation of Suricata and we used a jump host, that equipment gets used for other workshops. So I can't guarantee that. Was also an IDS? I've demonstrated that it is a host-based intrusion detection system, or at least it does the alerting on that. Can you demonstrate man on the middle attack in this lab setup? As in the Wazoo lab setup? It's a little bit harder to do, but essentially what you want to try and do, if you've got 3 machines, you basically have a source and a destination machine. And depending on what sort of communication they're having is where you need to figure out your man in the middle attack. True? So if I'm just using machines to do that, if we're on the same network, so this is the attacking machine. It needs to somehow knock the source off the communication channel or act as masquerade as each other. So depending on the medium that you're connecting to and what the communication channel is how you would do that man in the middle attack. One of the quickest ways of doing it is to have a rogue DNS and DHCP server on a network. So if I'm connecting to the Wi-Fi here, as part of my connection, I just run up a DNS server and a DHCP server. And then what will happen is that your machines will communicate with me to get a lease. Can I get an IP address? Yeah, here's an IP address. And then I give them a DNS that I control. And then whenever you want to communicate with that a particular address, I could act as that address because I'm now in control of your DNS. That is one of the simplest ways of doing it. There are more complex ways of doing that, especially if you're using IPv6. So there's the Hacker's Choice Toolkit. So that's not what I want. So this is an IPv6 attack toolkit, and it basically listens for router solicitations and neighbor solicitations and responds in IPv6 world. So most of us may not be using IPv6 actively. However, your devices have probably got that configured. To give an example, if I open up just opening up a new terminal window here. We can see here, I've got a linked local address. So IPv6 is prioritised over IPv4. So even though I haven't got a public IP address, if I'm on the same network as you, and I've been able to get you to accept a DNS entry for IPv6, I can now get you to start sending communications to my system using IPv6. So I'm not necessarily having to do a man-in-the-middle attack on IPv4. I can use other protocols there. It's probably not. We've got a lab on IPv6 where we do a man-in-the-middle, but I haven't got specific labs created. Is Wazoo cloud-based? No, it's not. It's a virtual machine. So yes, you can push it up to the cloud. I'm not too sure if there's any templates on any cloud providers, but you can do that. But then you've got to be aware, how are you going to get your agents to communicate to it in an encrypted format? So you'll need to make sure you set that up. And it is free, yes. If we enable all the monitoring tools available in Wazoo, how much system resources consumed by Wazoo agent on average? Not much. To give an example, we haven't enabled everything, but I better increase this. I'm just going to run the top command. You can't quite see it there. I'll do it on this system. So if you have a look here, currently my agent, if I can find it, there it is there, the Wazoo. It's not using much memory or using much CPU. It comes back to what you're actually polling and how often you poll, but in theory, it doesn't use much, doesn't consume much. For installation of Wazoo, any specific infrastructure configuration needed comes back to how many agents you're going to monitor. You need to think about redundancy and how big a data store you need for all the logs that you're collecting. So you'll need to do appropriate sizing based on that. My suggestion is that do a proof of concept for a base workload that would be normal for your organisation, and then see what the storage requirements is and beef it up that way. But if you're doing a lot of storage of logs, make sure you have fast hard drives. I'd look at something similar to the Suricata, where it said the 128 gigs of RAM, fast hard drive, 16 core CPU. But you're not doing as intensive as that. Can you tell us how to respond to a security incident? For example, what to do if there's an ongoing DDoS attack? That's difficult to say because your policies are going to be different. Your country requirements are going to be different. But essentially, you need to basically detect, respond, mitigate, and then recover from all that. As that process, so normally with a DDoS, you identify the traffic's coming in, and if you are able to, you black hole that traffic, but then you want to try and move closer to the source of where that DDoS is coming from. So you'd contact your upstream and get them to DDoS that. Now, if you've got a contract with a cloud provider, then that changes altogether, because then all you do is you just move your resources into the cloud provider's DDoS scrubbing service, and then your legitimate traffic still comes to you. You just start announcing it from their systems up there. So that changes depending on what you've got in place already. What is the easiest vulnerability assessment and pen testing tool? Rapid7's got some good tools. Nessus, they're really good ones, but they're expensive. There's Qualys as well. That's very expensive. You're looking at more than 25,000. And then you've got to buy all the hardware that goes with it. So yeah, so Qualys Guard, that's quite a good tool, but too expensive for the most common person. Are logs inside the Wazoo server, or are logs stored in a separate server? They're inside the Wazoo server at this point. We've done just a standard system, but you can always change that configuration. As I pointed out, you can get it to move the logs to somewhere else. And inside that configuration file, you can move that. Any questions apart from what's there? Some good questions there. I should take up consulting based on all these questions. Nah, I have too many memories from doing consulting. I'll just see what's happening with my agent and see if there's anything else I should show you. So if we go to tools, oh, that's the API. This is where I'm creating my rule set so I can test it. Should show you this one. This one's quite good as well. So there's a framework from the National Institute of Science and Technology. So if you go down to regulatory compliance, depending on where you are and who you're working with, there are different regulatory compliances around the world. So I can't seem to scroll down to get that, but essentially I went to the compliance for NIST. So if you're working as a contractor for the Department of Defense or some US government agencies, you have to comply to a certain standard, and it's that special publication 853. And in here, this is where it's showing the different parts. So yesterday when I was talking about session analysis, I pulled out that NIST framework, cyber security framework, and that's what this is related to. So if we have a look here, we've got our different alerts coming up, and I can go up to the events and it's going to show me what it is alerting on. So it's listening ports here, successful sudo to root executed, and I can go drill down and find out what that is. But on the left-hand side are the controls for the configuration, and my window is terrible. Oh, I can't. I can see my requirements here. There's 198, but my view is not good. So this is my configuration management requirement. So if I click on that, it's now going to show me the filter for my configuration management. And I can't scroll to the left to get to the scroll bar to show you what's there. And it's not accepting my mouse. Oh, let's see if I can make that. No, you'll have to do it on your machine unless, wait up, give me a second. That didn't help. I'll do it this way. There we go. It allows me to then have a look at it. Sorry that it's going to be very tiny, but we can see here that I've got now different categories under the configuration management. And so I've got unsuccessful logins, response to audits, develop security, protection of audit information. So I can click on that and it now gives me details. So there's no events for that. So I need to choose one. Oh, yeah, it's got 0 there. So I can say hide 0 ones, and now I can go and have a look at this. Develop a secure testing and evaluation. And this gives me information about how I can do that. So the thing I like about Wazoo, it has some of these built-in security frameworks as part of its implementation. So it's making it easy for newer people to the industry to install it. At a minimum, I would suggest running this in your home environment. If you're looking after more than one computer at home, experiment with it at home. Run it and see what it's like. Doesn't cost you anything, just time and energy to maintain it. Or if you've got a lab environment, run it in there. Any questions? Oh, that looks like another question. No, it only detects the vulnerability. It doesn't mitigate against the vulnerability. But it will give you links to go get the information. So it's not a deployment server as such. So you need some other tool to do that. Yeah, so just start the lab again and just work through it. And if you've got questions, feel free to ask. Raise your hand, get my attention, I'll come and help you. And I'll hopefully see the update complete. If it doesn't, I'll then force it to use my download. Does everyone know what we're doing? Yep, start the lab and start working through it again. So someone asked before lunch about infrastructure and how you would deploy this in production. It comes back to how many machines you want to manage and what sort of redundancy level you want. So you could easily monitor 100 systems with just this simple installation. Now, this installation is one Wazoo server and everything running on that. And then the agents connect to it. You can deploy it in a staggered approach or a staged approach. So you would have your web server, your log management, your log collections and so on in different locations. And then all together they run to share the information. But it comes back to how many systems that you have and what sort of redundancy you want. It's beyond the scope of this tutorial to show you how to do a cluster deployment of that, but it is that capability where they act like one big deployment cluster. And you can do lots of things with it from there. So that's getting the systems into our format. Now, the issue that we had was looking at some of the different management and different rules and roles that you can set up. And this is where we've got that status report for the cluster and statistics and logs and reporting. I haven't really covered that because that wasn't our focus. Our focus was just to get a machine in, do some vulnerability scanning, which didn't work, unfortunately. But there are these management tools that you can go have a look at. And not only that, you can break out the different components to different groups. So that way you can apply different standards and policies and configurations. If we click on the configuration, these are for this server. What my alerts are, what my auditing policies are, what my vulnerabilities are, and so on. So each one of those, say if I click on log collection, this is where you can modify settings. So it's showing you where the log collection is. So if you now want to move that to a central spot or have backups of that, you can go and change that. There was a couple of questions about integrating it with other logging systems. So even though I said do the lab again, you have free reign to this. Go click on things, experiment, break things. If it doesn't work or you've made so big a mess, just restart the lab. It's there for you to experiment with and use. If you want to put it on your own system, there are mechanisms where you can download the VM and set it up if you want. But the idea is that if I click on this audit log, hopefully, this is where I can. So these settings, this configuration is coming all out of that conf file, that ossec.conf file. Instead of you having to read the 200 and something lines of code, you can just use this GUI here. The disadvantage is that you can't really change it. So you've got to go back to the original. So if I click on settings, it doesn't really do anything. If I just want to have a look at the JSON format, this is what it looks like. Some of the commands that we can run to find what you're listening for in the configuration, you go have a look at that there. There's so much in here. So that was the management section. Under the tools, you can add rule sets for testing. So being able to connect or something, it's another custom thing. API, so you can modify other information, or you can have it integrated to other systems if you're wanting. So it talks about what the API is, how you can get access to it, and then you can test it on the left-hand side. Can't remember what's under miscellaneous, so I'm just going to click on that. If you make changes and you want to do a check to see that everything's running correctly, you can do execute in debug mode, especially if things aren't working as expected or it's really broken. Debug mode will start being a bit more verbose in that logging. This is our current app settings. Log levels, known fields, a lot of information that you can modify and change in here. So currently, I've just added my two systems and it looks like I've got 421 events. And it's probably because I'm using SSH to connect. And I've got my Wazoo server as a local agent, and then I've got these two other agents there. And it's got my CIS benchmark being completed or less than 50%. I've got some other agents that have been scanning in the meantime. And so it gives me some great information. One thing I didn't point out is up in the top right-hand corner, you can use this to generate a report. And that report is going to then give you a nice little graph of different things there. Actually, it doesn't turn out like I thought it would, but there was a different... OpenVAS has a nice report as well. I can easily jump back to a particular agent and only focus on the alerts for that agent. And then once I've got that agent up here, It's going to show how many alerts, and I can generate a report based on that system if I want. Any questions about that?
Is it possible to run the project for the website? Is it possible to run the projects?
Or the cron jobs for the log files? Yeah, you can always run cron jobs.
Is it done from the UI or you have to do the manual?
You'll have to do it manually. This is just a UI to the conf and to the storage of things,
Yeah.
but you can't update.
Log files.
Yeah, so actually, if we go have a look at the agents and you drill down on a particular agent, you've got this configuration here. So you can go have a look at that configuration. This is the logging settings that apply to the agent, not the actual system. So if we click on that, it's going to log it in plain text, not in JSON format. And that's applied, this general setting is applied to any agents in this group. So what you would want to do if you have custom settings, you create a group, maybe this room number, and then you apply it based on that. I don't think I've got logs. Log collection. So this is where the log files should be stored on the agent. And it's redirecting it to this socket agent. So it's got log sys and so on. So again, I would go to the agents and I would then have a look on the OSSEC conf file and modify that to point it to somewhere else. These are some of the commands we can use and what sockets not available at this point. Notice up here the agent name or the host name of the machine that we're looking at. Someone asked about cloud. Looks like there's options now to monitor some cloud providers. So Git, Amazon, and Google. Not Azure. In regards to incident response, someone asked about that. I tend to treat it like an investigation. You want to know what happened, when it happened, where it happened, why, who, and how. But it also comes back to your business risk and the business impact. So when I work for managed service provider, most of my clients, they didn't care about this. They just wanted to get back to business as quick as possible. So usually the quickest way was to redeploy a backup. So just delete the system, re-image it, and it'll be back in about 15 minutes. And then you would you'd lose all that evidence of what happened, and then you would have to try and figure out exactly what happened from logs if possible. So that would be the only thing. Whereas when we're looking at the analysis, we want to find out this sort of information. What happened, when it happened, how did it happen, so I can go back and fix it. What I'm going to do is close down this lab now. The next week or so, I'll experiment with that vulnerability database, and if I get it working, I'll update the instructions in the Academy virtual lab, so that way you can go through and do it later in the week. I just want to start covering a quick intro into what a honeypot is. Can I get everyone to go to the event page? And in the event page, I'm going to start off with talking about canary tokens to start off with. Both honeypots and canary tokens are a type of deception technique that you use for defending your network. The deception technique is where you basically put a decoy somewhere to attract attention, and then if someone goes to that decoy, you get alerted about that. Does everyone understand that? So, example would be if you're trying to capture a bird, you're going to put some bird seed down, and then you might have a cage above the bird seed. The bird is focusing on the seed, walks under the cage, and then you drop the cage and you capture the cage. So the bird seed is the decoy, and you end up getting the item. The other thing is some deception technology is just trying to keep the malicious person busy long enough for you to detect them. So there's a tool which I can never find. I've used it a couple of times, but I can't find it anymore. For websites, it's called Labyrinth. So there's tools like GoBuster or DirBuster, which dynamically scan a website to find all types of folders on that website. This tool called Labyrinth basically says yes to any request for a folder. So they end up getting a list of all their word lists as being a valid folder. So that's a problem. In this example here, can I get you to open up the very first link for the canary token? So a canary token or canaries come from the days of underground mining. When you are underground, you sometimes come across different types of gases, and those gases could be fatal to the miners. And so what they used to do is carry a canary down underground in the cage, and if it dropped dead, they knew there was a gas leak, and so they had to hightail it out of the tunnel. And this is what the idea of this. There's a whole heap of canary tokens that are free for you to create. And when it first started out, it was a very simple type thing like a URL. Now, if you click on this drop-down list, there's all of these different types of canary tokens that you can set up. Anything from a unique email address. So if someone tries to send an email to this unique address, you get alerted about that. There's a Microsoft one up here, Azure login certificate or Azure Entra ID. So if someone tries to log in with these credentials, you get alerted about that. You can also create a suspicious Windows command. So you can rename a command, and if someone goes and runs it, you get alerted about it. In its simplest form, you could do something like if someone opens a Word document. Going back here, there are two examples. On the canary token, if I do a search for QR, so up here, QR, it jumps down to a QR code. I click on that and I can put in a valid email address or a webhook that goes to, say, Slack, somewhere that is being monitored. And then something about what the QR code is to do with. So you might create a QR code and put a sign on a server rack and say, scan this for a network topology map. That way you know if someone's in your server room. So you're using some sort of deception technology. If we change it to a Microsoft Word document, again, the same two things, an address, an email address, or some mechanism to send it to a Telegram, WhatsApp, Slack, or something like that. to alert you if there's something there. And the idea, you put a reminder there, and this might be list of executive passwords.doc, and you store that in a public folder. So anyone that's just browsing your shared folders comes across this, oh, what's this? Double click, you get informed about that. And it's going to capture things like IP addresses or so on. I would suggest if you've got a QR code scanner, try filling it in with your details and it will present you with a QR code. Scan it and see what email you receive. These two are not configured to my emails. They're for other people that wrote this lab. I'm not changing it to mine. They keep saying, change it to your email. I go, no. So I'm suggesting instead of going to these ones, can you create your own? So I don't get in as much trouble from Jamie and Adley. If you want to run your own version of that, so Open Canary is your on-prem version. So instead of using the website where you're sharing maybe sensitive information, what you can do is you can download Open Canary and run it in your own environment to do the same sort of process. And what it does, it just basically listens for different types of direct connections on your services using Python and a few other things. So let's get into talking about honeypots. The idea for honeypots came from one of the first cybersecurity incidents that were documented. So back in 1989, this person that worked for a university had an accounting error. He was charged 75 cents more for his computing time than what he actually used. And so he spent the next, I don't know how many weeks, figuring out how it happened. And he then set a trap for that. But essentially what he discovered was that there was someone logging in under false pretenses or unauthorized accessing the computing lab equipment and doing some programming and running programs. And it cost him money. So he then wrote this book. Really good read if you're interested in it. And he's also become quite proficient, but he talks about all the techniques of investigation. But the idea is to learn from a breach system. How did they get in there? Remember that slide I just showed you before? What, how, when, where, and so on. You're going to have to try and figure out all that information. But sometimes businesses won't let you do that. So this is where honeypots or deception technology helps you find out what's happening. What are they trying to do once they compromise your system? And there's a couple of ways that you can do it. And that is we're going to emulate what is a real system. And then we need to somehow attract people to log in or attack it. Once they are in the system, you now collect and log every command they do, which websites they go to, what scripts they run, and any downloads they do. And the idea is that you've got that under control. There are techniques where they can be bypassed, but we won't get into that. But essentially, it means that once we are able to monitor what they're doing, we get to learn about their scripts, what IP addresses they're using to download payloads, and we learn some of their techniques on how they attack systems. Based on that, we can now start hardening our systems. And there's different research teams out there that use these technologies. APNIC has an active HoneyNet project. And a HoneyNet project is just a group of honeypots that we run in various networks around the Asia Pacific region to collect threat intelligence. If you are interested, you can access, I think on the events page, I put a link. Yes. There's a link here to the APNIC HoneyNet project blog, and then this is the dash tool that displays the strange traffic. A honeypot is just a system that is going to be used like a normal production system. And there's two types. There's the low interaction, so very simple. So it will run things like SSH and Telnet. And then high interaction, where it is like the real thing. And there are sandboxes out there that you can pay lots of money for to basically do emulation of a full-on Windows environment or Linux system and running everything. The disadvantage of the high interaction is that it's very capture extensive. So you need to have good systems to be able to capture everything in real time. But it also means that you're more likely to have escapes from that sandbox, or something could go wrong because there's a lot more complexity in that. The one that we're going to install today is going to be a low interaction used for Telnet and SSH. And then you've got server-based honeypots and client-based honeypots, depending on what you're trying to do. The reason why you do it, one is for detection and the other one is for deception. So being able to defer or stop someone getting in there. This is a very old slide. I should have removed it. I thought I had removed it. But essentially, this is an old, early virus that attacked systems. In a web honeypot, you're going to get things about the IP address of your system and then who is attacking your system and this unique code and what they're downloading. So this is of interest for us to have a look at. Other information you might get is the session details, so you can go back and have a look at it when we replay the attack. And then you get things like the source IP address, the username and password that that system used to get access to this system, to the honeypot. And the same over here, we can see the username root, the password quad A. So this is like what MirrorBot does. It uses default credentials and common passwords to try and get into the Internet of Things. Once we've got details about the IP address, what did we do yesterday with an IP address? We went to a third-party site and checked the reputation, didn't we? So you can use that to do the same. Also, we can see here that it downloaded a file. What we can do is use that information to then do a lookup on the file and see whether it's malicious or not. Just like what we did yesterday with Security Onion, where we extracted the file, and also Suricata, we extracted the files and went and did a reputation check on that. So in the back end, this is what an attacker normally does. The attacker is going to make an initial connection to the honeypot. It may download some information, but usually it may go off and call to a command and control server as well as another download payload server. And so you're now capturing information about the initial connection and any other sort of call home connections. So you're gathering a lot of information from that. Honey tokens or canary tokens are resources that only exist for alerting. And I showed you an example of that with the canary tokens, how we can do a QR code that sends you an email or a Word document when open, sends you an email. And the idea behind that is that it's deception. So that way people look like it's a legitimate document, they open it, you now get told that someone's opened that document. So now you've gone to detection. So it's a combination of both. And we've looked at this already. If you have a look here, this is an example in a file server. Someone's created these two documents, infrastructure, network infrastructure-notes.docx. And you can also set it up as a PDF, so server setup-latest.pdf. So a malicious actor is going to come in, find those documents. Oh, that's interesting. And if they download those documents to their own system, so they exfiltrate it, you will also be told their IP address when they email you, depending on the canary token that you've got. So there's actually a good story, a good presentation that was done at CrikeyCon 2 years ago. There was a pen tester. That was his day job. He got paid lots of money to go and break into systems. And he had all these malicious tools that were on his laptop. And someone broke into his computer, somewhere in Europe, had gotten into his computer and downloaded his files. And then they opened the files and infected themselves and created a reverse shell back to his command and control server. So he could now get back into their systems and delete his files. So he did an interesting talk about that, more about the Australian legality side of that. And this is, if you scan this, you'll send an email to Jamie or Adley. So that's what the token looks like. There's lots of different software out there. We're going to be setting up Cowrie, but you can go and have a look at that. And there's a good GitHub repo where you can go and do a comparison and install the various ones. Some other tools that you may want to get is a mechanism to be able to move the collected items off the honeypot to a central location. Then if you find any malicious or you get any executable files, you want to execute those or investigate those in a safe manner. So use some sort of sandbox. So there's the Cuckoo sandbox or Viper. And the idea is that you detonate the payload and you see what it does, or you start reverse engineering it. There are threat management tools out there that add enrichment to it. So the Hive or Cortex allows you to ticket what you've seen, and then other people can add to that. And then you can run it through other tools like Suricata. We haven't touched on Zeek at this point, but there's all these other tools that will help you. But essentially, whatever you are trying to do, you need to figure it out, and that will influence which honeypot to use. At a minimum, if you're running network equipment where you're SSHing into, you should have an SSH honeypot, so you can see if there's any strange traffic happening on your network. If you are interested, you can talk to Adley, our security specialist that looks after the HoneyNet project. And if you want to run a honeypot in your network and share that information with APNIC, it would be very much appreciated. But essentially, we have a whole heap of honeypots in the Asia Pacific area. They're giving feedback to our community HoneyNet project. We use encrypted connection and file beats to take that information, put it into Logstash, and with Elasticsearch, we start building visualizations and alerts on those information that we've gathered over on these endpoints. And with those alerts, we present it inside Dash for the different ISPs. So we'll say to an ISP, we've seen these address blocks from your prefixes or your IP addresses. You should be maybe investigating further. We also give that information to the national CERTs, Computer Emergency Response Teams, Computer Security Information Response Teams, telcos, and so on. For more information, go there. And now that should get us up to the afternoon tea break. And spot on. So let's have a break. Stretch your legs. We've had, you had a bit of time to play with the virtual labs, so hopefully your brain's refreshed for the afternoon. When we come back, we're going to start the Honeypot Lab. And it's on the Virtual Academy. In the past, I've been running it on our own equipment, but we'll see how it goes in the lab. If the latency is too bad, I'll spin up our equipment in Brisbane for you to do it there. Okay. Yeah, I agree with you. It is very hot and it's hard to concentrate, especially today. It's been very hard. That is true. It is a little bit more than just an intrusion detection system. It's a full-on endpoint protection system. I wouldn't just define it as an intrusion detection system. It can also do prevention and quarantine and things like that. So it's a lot more, and it does vulnerability scanning, it does compliance checking, it does security audits. So it's not just an IDS. Nessus does a lot more than Wazoo, but it's more, it doesn't do endpoint protection, I think, unless it's changed. Again, I haven't used Nessus since about 2010 because it's gone a commercial license and I can't afford that license unless a client pays for it. So in regards to the offline, I did share a link for you, but you can do it via, I'll put a link to this document I wrote just before. So you can use this. I've just gone into a temp directory and then I've grabbed the feed using this gzip, this HTTP there, and I'm making sure that it's encoded with the binary. Sometimes when you use curl, it won't use the right encoded method. And so when you download it, it's not going to have the right type of file. It will be like a mixed up ASCII. And then I do the same. For this one, I couldn't quite get it to work. So I end up just opening up manually and copying across. And then these are some of the commands I used today that you can have a look at. So remind me I'll upload those later. For Wazoo, you can just do a simple friendly neighborhood search. You go to wazoo.com and you've got this install Wazoo. And it allows you can also get professional support and training courses for it if you want. There's also a cloud instance that you can purchase. And you've got these 3 different components and you can separate those out. Or you can get a single setup. So you've got an installation guide there and it tells you how to get started and install it. So if you want the indexer, you do that. If you have a look in the top left-hand corner, or sometimes it's in the top right-hand corner, you can look for older versions depending on what you're trying to achieve. I'm not too sure about that. The CIS integration, whether it needs to contact the database. I'd need to go have a look at the documentation for that. What is the Wazoo database function and does it need external connection to get updated with latest vulnerability information, or this can be handled in local server itself? So you can manually update the national vulnerability database, but I've had issues with that command. But yes, you can do it locally. You can keep it isolated off the network if you must. And it's usually probably safe to do that. So if I can get everyone to continue with the Honeypot Lab, that would be appreciated. I'll try not to talk at the same time, so that way you concentrate on your lab and I'll concentrate on mine, and then I'll show you what you should see at the end. How many people have used IP tables before? So in the Linux operating system, it uses a Berkeley packet forwarding agent engine software package to look at the packets as they come in and out of the system. That's a very old mechanism of doing it, and there's different types of firewalls, and we end up getting IP chains to make it a little bit easier, and now we've got IP tables. IP tables is just a simple term of creating a table of what is allowed traffic and what is denied traffic under certain categories. So what we're saying is that we're looking at the sudo IP tables -T, we're looking at the network address translation table, and we're going to -A, which is append this information to that table. And we're saying for pre-routing, we're going to modify -P, the protocol TCP, anything going to -D port, which is destination port 22, we're going to redirect it to 2222. So we're doing that for our SSH. I did say I wasn't going to talk, but, and then we do it for our 23. And Actually, I made a mistake. I forgot to change that one to 23. It's capital L, so I should do the capital L. See how I've got 22 going to port 23. So it's not going to really matter too much because it's going to match on this one first and go there. But I should do a delete. I tend to save it to a file first using net tables, and then I go and just delete the table. That way, I never use the onboard one. So it's if I knew the number, I could get rid of it. It's usually -D for delete. Yep. So -D is going to delete it. So make sure when you do the next one, you're doing 23. See, I've got 23 here and 23 here. Now, when I view the table, we've got 22, 23 going to the appropriate address. So I'll be quiet, leave you to it. So how's everyone going? You've been able to get the out-of-band management set up, the IP tables, the virtual environment, and you're starting to now test it. So I've tested mine. I've logged in using a different session, and I can go have a look at my variables. Now, I'll get you to do the print working directory, because what you've got is you're logged in as Cowrie. You're working in a folder called Cowrie. Now, that's important because it's a honeypot. It has a virtual file system. And if I do a ls at this point here, there are different components inside here that are going to be, that will help you modify the way this looks. But you can see how we've got this etc directory. We've got a honey FS directory. We've got a var directory. We also have a Docker directory. So if you want to run this as a Docker container, you can, rather than running it as this sort of system. So we're going to go have a look in the var log Cowrie directory. In particular, we're going to look at the Cowrie log. And that's what this command's doing here. So I could do a tail. This basically, I've just got to keep hitting press until I get down to the bottom, and I should now start seeing an SSH, or actually what we can see here. Can you see how we've got this CMD? Change mod +x evil.sh. So it's showing me commands that you would have typed in. What we're interested in is looking for the IP address. So we've got this 192.168.30.254. So this log file is important. So if you've got multiple honeypots, you want to basically use a cron job or some mechanism to rsync these to a different server. What it also does is it creates a random string of characters here. And this is the recorded session of that activity. So if I logged in more than once, I would have multiple versions of that. So you'd need to use something like ls-lah, and that now gives me the timestamp to go with that. So I can then figure out the times that it occurred. Obviously, this system needs to have the appropriate timing to match your systems. Now that I've got that, what I can do is use that strange character there and copy and paste it there. But because I've only got one in there, I'm just using a wildcard. So I'm saying use this software bin play log var and then play this file here. Now sometimes or lately that play log installation has been corrupted, but in this case it's not, so that's perfect. So if you have a look, it's replaying what the attacker has done. So they've logged in, they've done an ls, they're now looking at the script and they're trying to run that script. Didn't work, and so they're using a different mechanism to try and run it. Didn't work. And then eventually they're going to exit. And that's it. So we can see what they're typing. And that's useful, isn't it? Especially if you don't know what the threat actors are doing. You can learn some good techniques. They've got some good scripting skills. Only disadvantage, though, is that there's certain giveaways that this is a Cowrie honeypot. So there are now anti-deception tools on the market that basically will check to see if they're in a sandbox or a honeypot, and they will be able to then not do the attack. And I had a website, and I can't remember where I put it, that had, it's a GitHub one. No, maybe I've got it in Brave. I had it open the other day and I was going to put it in once we got to this topic. Now, I'll have to look for it a bit later on. So this is something a little bit of an extension to the honeypot. Oh, that's just if it didn't play. You can download the play log itself if it doesn't play, but they've fixed it now. So an extension is if I change into my HoneyFS directory and do an ls, this is my basic virtual honeypot file system. So I can now put canary tokens in there as well. So I can go create that canary token and put that in there. If I have a look at the ls etc directory, I've got similar files as if I would be there, and in particular, I've got the password directory there. So inside that password directory, there is a password based on my system that's been pushed into that. So that's probably not a good idea. If we do an ls and go into the, I think it's the etc directory, we've got that user db.example. So that user db.example, if we do a head on that, that's where you can add extra users. And that's going to then build out a listing of users that are not default that Cowrie can use. So currently it's going to accept any sort of combination, whereas you can have a specific one. So if you know that some of your accounts have been leaked previously, you can add that here and see if they've been actively exploited. Obviously, you would have changed the password by then. You don't use live usernames and passwords. But in that conf.dist file is a lot of configurations that we can set up. Now, it's going to be overridden each time, but this is what it's trying to do. Essentially, the sensor's name, you can change it to something else. And so it builds this dynamically for you, where it's going to store the logs. And we can see here that we've got the default as being server 04. So you may want to change that to something different. Web server 01. The directory where virtual files are kept. So the actual file system is kept in file system underscore file, see below, and we can see Honey FS. Then the commands that they can use, user bin vi, and the pathings that you can do. So this is where you need to read the documentation and modify, so that way it's a little bit harder for the malicious actor to determine that this is a honeypot. I think that's all I want to share with you. Yeah, there's not much in there, that's more. But as I said, have a look at the documentation and look at ways of changing the default configuration so it's harder to be guessed about that. So install, this is the steps that we went through, and then we're at this point where you can go and modify Cowrie. So in here, you can go in and change things. That's it. Because we're running it in a virtual instance, if I exit out of this virtual instance, so I'm just going to, thought I clicked in there, and let's try again. If I go exit, see how I'm no longer inside the Cowrie virtual instance. What do you think will happen to my honeypot? So if I go new tab and I try to connect, it's still there. Okay, so just be aware of that. Sometimes if you restart the server, it's not going to restart that honeypot, so you need to set up either a cron job or add it there. Now, in regards to this command here, I've sort of used a technique to make it, when you SSH to something, it then exchanges a certificate with each other, and you get a fingerprint of that connection, and then you add it to a known host file saying that you trust doing this connection with this server or this connection to that. Because we'd SSH'd with the outer band network, it had already got a fingerprint. So all I'm doing is a technique to bypass that fingerprint. That's why it's saying, do you want to accept it all the time? Otherwise, you're going to have to delete it from the known host file, connect, and you'll get the issue. That's the only reason why I've got that there. Has anyone set up a honeypot already in their environment, at work or at home? I run my honeypot on a couple of VMs. And every so often I'll build one in Azure or I'll do it in AWS just to see, because then it's got a public IP and just to get some threat intel. Whereas I always run one at home, so that way if anyone's on my network trying to snoop, I get an idea. Sometimes, well, my daughter's not living at home anymore, but when she has parties, it's interesting to see what people try to do on your Wi-Fi if you don't isolate things. So it's always good to put a honeypot there. Obviously, you have a guest Wi-Fi. Any questions? So we've covered a lot of information today. So we've taken it from defining what your assets are, looking at the vulnerabilities of those assets, trying to test the security of your environment, doing packet analysis, to being able to automate that packet analysis using tools like Suricata and Snort, and then a security monitoring system like SecurityOnion. Today, we've moved towards endpoint protection. So not just your network, but the endpoint components as well. Because remember, your security is only as strong as your weakest link, because the attackers only have to get one thing right and they're in your network. So we're trying to get a more holistic approach of looking after everything. Just don't focus on the router. The router's not going to, if you secure that, still doesn't mean that you've got the best security on your network, okay? You've got end users. There's always going to be issues. Tomorrow, we're going to look at the next part, which is our log management, being able to have tools where you can start correlating that. And there are, the Wazoo server is a SIEM, a security event and incident management tool as well, because it correlates information. But we're going to look at generic just log setups using maybe not all of the servers, because they could take all day to set up, but we've got rsyslog, syslog and Graylog as examples. There's been some discussion about what time we're going to finish tomorrow. That's up to you. So my schedule is that we spend the morning looking at logs. The afternoon, yeah, you got. So you should be able to log in again. You just need to change it to your management port, which is -P 2200. So can you log in on that -P 2200? That should be your outer band. Otherwise, yeah, if you try to go 22, it's going to take you to the honeypot. Yeah, okay. So the morning part is setting up logs and using different log servers. The afternoon, I've created a capture the flag. So some of the content that we've learnt this week is in a Jeopardy style questionnaire, and you then go download packet captures and answer questions about that. That can take as long as you want. So if you only want to do 1 hour, we'll do 1 hour and we'll announce winners, and the winner will be the one with the most marks, essentially. So we will need about 15 minutes for everyone to connect and log in, and then we start the capture the flag. And then if you want it to go for 1 hour, 2 hours, 7 hours, it doesn't matter. I don't fly out until Saturday night. So. Yes, we can finish in the afternoon. Only thing I need to know is when to announce the winners. I'm sure you want to know about that. Yeah. So yeah, the afternoon tea, we can finish. So we only have a 90-minute session then, depending on lunch. We could start it, you go get lunch and come back and start early. I don't know. Any questions? I think we're done for the day. Everyone ready for the exam tomorrow?
Study hard.
So,
Study hard.
study hard. Capture the flag. Thank you for your time. Well, actually, we're going out together, aren't we? So do we want to stay back and do more work? What time are we leaving?